So as I said, in this unit, we're going to look at technologies that have been developed specifically to take advantage of this network structure of the web. And one of the beauties of the web, of course, is that you can link between things. That is, of course, what makes it a web. So a metadata record can be here, but it points to a resource that's over here. Or linking between things allows us to also have namespaces. So again, a metadata record can be here, but the declaration of the metadata schema that it relies on is over there. Or, related to that, I can have some data, a data set over here, and my data set is related to your data set, which is over there, and we can both provide our data to some third party over here, and all of it will work together. Enter linked data. Linked data takes advantage of this linked structure of the web to link data sets together. And notice that it's not linked metadata, it's linked data. And that's an important distinction. Linked data, the linked data movement, is motivated by the data and the potential uses of that data. And in fact, in this whole unit, really, we're going to be riding this line between metadata and structured data. And we're going to get to certain points, and I'll try to point them out when we get there, where the distinction between metadata and structured data becomes very fuzzy and possibly meaningless. But the point is, linked data relies on metadata to make that linking happen, to make those uses of data sets reality. So while we'll be discussing linked data, we're not going to really address linked data in its full glory. We will just be focusing on the metadata aspects of linked data, which is a much larger subject than just metadata. If you're interested in linked data, you can learn plenty more about it than what we will be doing here. There are lots of places, lots of resources that you can turn to learn more, and I will link to some of them in the resources throughout this unit. What we're looking at here is the linking open data cloud diagram, the credits for which are down here. What this diagram shows is data sets that are published in linked data formats and are linked to other data sets. So the size of the circles roughly indicates the size of the data set. The larger the circle, the more data it contains. And arrows between circles indicates that there are links between data sets, and the colors indicate what the data is about. And you can see the key down here. There's media and geographic and publications and government and all kinds of subject areas on which data sets have been created. Now, if you've blown these slides up large enough, maybe full screen, you'll notice that DBpedia is right there in the center. Now, DBpedia is a project to extract structured data from Wikipedia. DBpedia is a project to extract structured data from Wikipedia, like these sidebars in Wikipedia that we've in fact already looked at. So again, let's take a look at the University of North Carolina at Chapel Hill. And this sidebar here has structured data about that entity, UNC Chapel Hill. And it's in fact already laid out as elements and values. Motto, lux libertas. Element, motto, value, lux libertas. Right? Chancellor, Carol Folt. Right? Element, value. In fact, you can even imagine that there might be some controlled vocabularies here. For example, type, flagship, and public. I don't know how many types of institutions of higher ed Wikipedia has categories for, but there are 2 of them being provided as the value for that element here. Now, Wikipedia is massive. It's massive in just the English language version, and of course there are, I don't even know how many different language versions of Wikipedia. So all told, there are millions of records in all of the various Wikipedia versions. Wikipedia has articles on probably more or less everything in the world. So naturally, DBpedia has at least the potential to have connections to data sets on more or less everything. And of course, there is a whole world of data sets out there and connections between them, and we are certainly not going to look at them all. There's just not enough time in the world to do that. What we're going to do in this unit instead is look at how those connections between data sets are made, because the data sets themselves, first of all, there are too many of them, and second, to be completely unfair, data is just data. It's the connections between data sets and the relationships between entities in those data sets and other entities that make it metadata. And that's, of course, what's going to be interesting to us here for our purposes. Now, in the resources for this video, I'm linking to 2 other videos on the subject of linked data that are short, and I strongly recommend that you watch them. The first one is a TED Talk by Tim Berners-Lee that he gave back in 2009. Now, you've probably heard of Tim Berners-Lee, and in addition to everything else that he's done, he's been a major driving force behind the semantic web and linked data and linked open data. And in that TED Talk, he really lays out kind of a grand vision of what linked open data can do. The second video I'm linking to is about linked open data, and it's from Europeana. Now, I've talked about Europeana before. It's a collaboration across dozens or maybe hundreds of museums, libraries, cultural heritage institutions, as they're called, of all types, all across Europe, to make the materials in the collections of those institutions available on the web. And Europeana makes heavy use of linked open data to connect materials and collections across all of its partner institutions. We'll return to linked open data later. Now, I encourage you to go watch those 2 videos, Tim Berners-Lee and Europeana's videos. Like I say, they're quite short, and they'll add, I think, quite a lot of depth to what we will be talking about throughout the rest of this unit.